Dear friends, I think that we'll be starting now, and let me start with a few slides emphasizing the reason why we are meeting here this afternoon in Krakow. We are meeting here because we all think that differential diagnosis in diabetes has a substantial meaning, that it matters. Just 20 years ago, most of us thought that we had two types of diabetes. Type 1 diabetes diagnosed mostly in children and adolescents. We thought we had type 2 diabetes diagnosed mostly in adults and in elderly population. However, after the 2 decades of intensive research, we know that this is much more complicated than that. We know that there are many more forms of diabetes, and they were discovered over those 2 decades. And we are meeting here because we are aware that the proper diagnosis of the forms that I am showing to you has a substantial impact on the medical care, on the prognosis, on the treatment for the individual subject and within the family. So the reality in diabetes looks like that. The most frequent types of diabetes, type 1 and type 2 diabetes, plus many more forms of diabetes, such as MODY, neonatal diabetes, mitochondrial diabetes, rare insulin resistance syndromes. True, they are rare. Sometimes they are very rare. But on the individual level, the proper diagnosis has critical impact for those people. And we are meeting here this afternoon to know how to search for them and how to treat them properly. And most of the forms we'll be talking today are monogenic forms of diabetes. Those forms occur due to the rare mutations that are totally responsible for the occurrence of the disease. So this is a small, I would say, scientific introduction. And before we go to the second part of the introduction, I would like to emphasize that we are able to meet here and to discuss all those issues because there are dear friends, there are colleagues from abroad and from this country who came here to share with us their clinical and scientific expertise. And at this point, I would like to very warmly and cordially welcome them. So I would like to welcome the guests from the UK. I would like to welcome Professor Catherine Owen from Oxford. Catherine, thanks very much for coming. I would like to welcome Dr. Gaya Tanabalashingam. Gaya, thanks for coming. I would like to welcome Professor Alessandro Doria from Boston. Alessandro, thank you for coming, for being here. There is also Professor Stephen Rich from Virginia. Steve is visiting the city now, so he will join us tomorrow, but I suggest to applaud him as loudly as we did for the others, and also for the record, as we are being recorded for the internet presentations. Steve, wherever you are, welcome. I would like to welcome all the friends, scientists, great scientists from this country. I would like to welcome Professor Wojciech Młynarski from Łódź Medical School. Wojtek, thanks a lot for coming. Professor Dariusz Moczulski. Darek, thanks again, Łódź Medical School. I would like to welcome Professor Tomasz Klupa-Tomek, Dr Katarzyna Cyganek, Dr Małgorzata Wójcik. Thank you. And I think that I was able to mention everybody. So again, this course is being possible due to the fact that they came and due to the fact that we have the funds from the European Union. And now I'm handing over the chairing to Catherine Owen. Catherine, where is the money coming from?
Hello and welcome. I'm just going to tell you very briefly about the CEED3 collaboration, which, as you can see from your programme and from the slide there, it stands for the Collaborative European Effort to Develop Diabetes Diagnostics. And they've kindly funded this course. So the aim of CEED3 is the development of diagnostic tools to differentiate specific subgroups of diabetic patients to allow individualisation of patient care. And the reason that we need this is because of the problems that Maciek has already presented today, and which you will hear much about as the course goes on. And this is a translational research area, so it encompasses basic science right through to patient care. And the construction of the collaboration was such to get expertise in all those areas. And the specific areas that are covered by the collaboration are the diagnosis of monogenic diabetes, which we'll hear a lot about today, the detection of an initial beta cell dysfunction. As you can imagine, if we could identify those people within the general population who are at risk of developing diabetes because they have a beta cell dysfunction, then we could focus prevention and treatment on those people, and it would be greatly advantageous. And also the detection of patients with type 2 diabetes who are at risk of early development of vascular complications, because of course this is the greatest cause of morbidity and mortality in diabetes. So these three areas were the areas where we thought we had the most potential to make an impact on patient care. And this is taken from our original application and just shows the sort of vision of the collaboration. So to go from discovery right through validation and clinical application, and then finally dissemination, which of course is partly what this course is about. So you can see that we concentrate on both human studies and model systems to identify potential biomarkers. And then these are the three areas which I've just mentioned: the monogenic diabetes, beta cell dysfunction, and detection of early vascular complications. So these early areas feed into the three main project areas, and then finally into dissemination and training. And I'll just finish by telling you who the key centres and individuals are in this consortium. So the lead is held by the University of Exeter Peninsula Medical School with Professor Andrew Hattersley, who, as I expect many of you know, has been a great leader in defining monogenic diabetes and neonatal diabetes. And then we have industry partners, Introgen and Proteomica, and various other university centres. Of course, I'm from the University of Oxford. We have Lund University, our current location, Barcelona, Brussels, Switzerland, Helsinki, and Germany, bringing together expertise in all areas from the basic science to the patient.